Have you ever really stopped to think about the clock? I mean, really think about it. It's on your phone, your wall, your wrist. It's everywhere. But that simple face hides one of the most incredible stories of human ingenuity ever told.
So let me just ask you this. What one invention basically runs your entire day? From the alarm that wakes you up to the moment you decide it's late and you should probably go to bed.
You got it. It's the clock. And its story, which stretches back thousands of years, is really about one thing: a relentless, almost obsessive human quest for perfect, absolute precision.
Okay, so let's dive in. We got to rewind all the way back to the very beginning to see how our ancestors first tried to get a handle on the idea of time itself.
You see, the first attempts were all about watching things flow. You had sundials, right? They just tracked the sun's shadow as it crept across the ground. Then you had water clocks. They called them clepsydras, which basically just measured the steady drip, drip, drip of water. Even hourglasses and candles were just ways to watch an interval of time literally burn or fall away. Time wasn't something you counted. It was something you watched disappear. But there's a pretty obvious flaw here, right? What happens when it's cloudy? Or, in the middle of the night? A sundial's not going to do you much good then. It was clear that we needed a way to track time that didn't depend on the sun shining.
And that need, well, it sparked a revolution. A total shift in thinking, away from measuring a continuous flow and towards counting individual, distinct beats.
And this is it. This is the absolute game changer. It's called the Verge escapement, and it showed up in Europe around the 1300s. What it does is genius. It takes a constant force, like a heavy weight pulling down, and it chops it up into regular rhythmic beats. This little device is quite literally the invention of the tick-tock.
And what's so cool is how simple it really is. So you've got a falling weight that's always pulling, wanting to make a gear spin. But that gear is stopped by this little rocking mechanism, the escapement. It just rocks back and forth, catching a tooth on the gear and then releasing it. Tick. Then it catches the next one. Tock. That simple motion is how you turn a smooth pull into countable steps.
And you got to understand, this was way more than just a new gadget. This was a massive shift in how people thought. For the first time ever, time wasn't like a river flowing past you anymore. It was suddenly a series of moments you could actually count. That idea changed everything. It's the birth of deadlines, of workdays, of efficiency, all because we could finally go tick-tock. But, okay, counting time was one thing. Those first mechanical clocks were amazing, but honestly, they weren't very accurate. The next great challenge was making that tick-tock super, super precise.
And the big breakthrough came in 1656 from a Dutch scientist named Christian Huygens. He had this brilliant realization that the swing of a pendulum is incredibly regular. So he hooked up a pendulum to the clock's escapement, giving it this super stable, predictable heartbeat.
Now, just to put this in perspective for you, those first clocks, the ones with just the verge escapement, they could be off by as much as 15 minutes every single day.
Then Huygens comes along with the pendulum and bam, the error drops to just 15 seconds a day. That's not just a little better. That is a massive, massive leap forward in the quest for accuracy. But of course, that created a whole new problem. A pendulum works great if it's sitting on a mantelpiece. But what about on a ship getting tossed around on the high seas? A swinging pendulum is totally useless. And for sailors trying to figure out their longitude, their position east to west, this wasn't just an inconvenience, it was a life-for-death problem.
So, enter our hero, a self-taught English clockmaker named John Harrison. This guy spent more than 30 years of his life completely obsessed with one single goal, building a clock that could keep perfect time at sea, no matter how rough the weather.
And what he achieved was, well, it was unbelievable. On its first big test in 1761, his clock was on a ship for 10 weeks, sailing through rough seas. And after all that time, the total error was less than 5 seconds. It's not an exaggeration to say he solved one of the greatest scientific challenges of his time and made the world's oceans safe for navigation. All right, so now let's fast forward into the modern era, because this is where the clock's heartbeat goes from being a mechanical swing to something totally invisible, ridiculously fast, and almost unbelievably precise, an electric pulse. So think about it like this. Everything up to this point was physical, right? Pendulums swinging, springs uncoiling, things you could see. But the next leap was to quartz clocks, which work on a totally different principle. You use a battery to pass a tiny electric current through a sliver of quartz crystal, and that makes the crystal vibrate at an incredibly stable frequency.
And the secret to its mind-blowing accuracy? It's all about speed.
When the first quartz watch, the Seiko Astron, came out in '69, its heartbeat wasn't a slow tick-tock. It was that tiny crystal vibrating, get this, 32,768 times every second. That super high frequency is what makes it so much more accurate than any mechanical clock could ever be.
But of course, humanity wasn't done. Today, we have atomic clocks. These don't measure a swinging pendulum or a vibrating crystal. Nope. They measure the quantum vibrations of atoms themselves. The accuracy is so insane that an atomic clock would be off by maybe a single second over the entire age of the universe. It's so perfect, in fact, that we now literally use the vibration of these atoms to define what a second is.
So, okay, we've gone on this epic 4,000-year journey from sundials to atoms, but what does it all mean for us? Why does any of this matter to you, right now, in your daily life?
Well, here's the big takeaway. Nearly everything in our modern world runs on this insane level of precision. That GPS in your phone, it works by calculating tiny time differences between signals from satellites, all running on atomic clocks. The internet itself, it relies on those clocks to synchronize all the data flying around the planet. Financial markets, air traffic control, scientific research, none of it works without the shared, ultra-precise sense of now that was built over millennia.
You know, when you boil it all down, this whole journey comes back to a really fundamental human need. The need to chop up the huge natural rhythms of days and seasons into smaller, more manageable pieces that we can actually use.
Which, I guess, leaves us with one last question to chew on. We've spent 4,000 years getting better and better at measuring and controlling every last nanosecond. But in creating a world that depends on that perfect, unforgiving clock time, after all that work mastering time, is it possible that now time is mastering us?